All right, we're going to continue with a little bit of stuff about circuits. So when we talk about circuits, usually you're talking about more than one thing hooked up to a power source, or in some cases, more than one type of power source. We're going to start with fairly simple circuits that only involve resistors. If you take apart almost any electronic appliance, you'll be able to find resistors in there. You'll find things that have resistance, but there'll be more complicated things as well. But we're going to kind of focus on resistors. But when we're talking about it, there are two ways that you can hook up resistors. One is called series. That's basically where you have a bunch of resistors all in a row. Like a TV series is a bunch of episodes in a row. A series circuit is a bunch of resistors all in a row, and there's only one path for the current to follow. It can't diverge anywhere. Any current that goes through the battery, so the battery is kind of like a pump for the current, it pushes through the first resistor, all of that current goes through the second, and then all of it goes through the third. You can't have anywhere else for the current going through there. So if 3 amps goes through the battery, 3 amps goes through R1, 3 amps goes through R2, 3 amps goes through R3, and so on and so forth. They don't have different amounts of current. It's just they'll have different electric potential differences, different voltages. So in a series circuit, basically from the battery's point of view, you can pretend that it's just one equivalent resistance, as if it was just one resistor. It doesn't really care, like your power company doesn't care which appliances you have turned on, it just sees how much energy you're using. So for these series circuits, you can treat everything as just a single resistance. So with series, the same current I flows through each resistor. And then each resistor gets its own voltage drop, and we'll talk more about that later, but each one will have a certain amount of energy loss across that resistor. It'll heat up a certain amount, or it'll turn on a light, it'll do something. And so if you go around the loop, we'll talk about this again in a minute, however much voltage is provided by the battery, each of those individual resistors uses up that energy. So if you have a 9-volt battery and you add up all the voltage drops around that circuit, it'll equal 9 volts. So the resistance is the voltage divided by the current, just Ohm's law. So you add up all those individual voltages, but voltage is just current times resistance. So current times resistance divided by current. Basically, in a series circuit, because all of them are added one after the other and all of the current goes through each of them, instead of treating the resistances as something complicated, you just add them up. So if you have a 10 ohm, a 20 ohm, and a 30 ohm resistor all in series, you would have a total resistance of 60 ohms. But when you have individual batteries, basically, though that should say I times R1. I'm not quite sure what happened there because I just copied it for the second one. The voltage is I times R1. Delta V2 is I1, I times R2, and so on and so forth. Basically, if you go around the loop, so if you imagine you have like a 6-volt battery here, and then let's say 3 volts is dropped across R1, and 2 volts is dropped across R2, and 1 volt is dropped across R3, that's the way it would work. It gives you that same amount of energy. So the battery supplies the energy, the circuit uses that energy. So we'll look at exactly how to deal with those in some of the warm-ups as we go forward.